be delivered by Professor Rana, supposed to arrive from Bombay due to some unavoidable circumstances. He has expressed his inability to turn up. So, the coordinator of this program, Dr.Mallikarjun Holi, maybe intentionally he might not have put any session during these 4 days, thinking that if anybody does not turn up, he may immediately take up the session. So, he is ready to present before you the session, and I welcome on behalf of all of you from Department of E&I Department, the college, and on behalf of all of you, I welcome Dr. Mallikarjun Holi to present in this session, and I request Professor Jayadevappa to hand over a bouquet. Welcome, sir. Now, I take this privilege to introduce Dr. Mallikarjun Holi. Dr. Mallikarjun Holi, born on 15th, 1970 at Gulbarga, completed BE in Instrumentation Technology from PDA College of Engineering, Gulbarga University in 1993. He obtained MTech and PhD degree from Indian Institute of Technology, Madras in 1997 and 2004 respectively. He has 20 years of teaching experience and 12 years of research experience in the area of instrumentation technology and biomedical engineering. His research interests are biomechanics, rehabilitation engineering, biomedical signal and image processing, biomedical instrumentation and process control. He has published 78 research papers in national and international journals and conferences. Currently, he is guiding 5 PhD students for PhD program. He is carrying out 3 sponsored research projects funded by AICTE and Visvesvaraya Technological University worth of rupees 24 lakhs. Dr. Holi has received many awards. Among prominent are Institute Merit Award for the Best Academic Record in MTech Biomedical Engineering Program for the academic year 1995-96 from IIT Madras. Received Travel Grant Award from IEEE Engineering in Medicine and Biology Society for Best Research Paper in 28th Annual Northeast Bioengineering Conference USA in 2002. He received Travel Grant Award from International Bone and Mineral Society and Japanese Society for Bone and Mineral Research for Best Research Paper in the first joint meeting of IBMS JSBMR Japan 2003. He has been identified as subject expert in process control for the prestigious ISRO VTU educational satellite program for the year 2008. Dr. Holi is fellow member and life member of many professional societies and organizations. Currently, he is executive committee member of Biomedical Engineering Society of India. He is working as member of Board of Examination and Board of Studies of Visvesvaraya Technological University and Columbia University and for many autonomous institutes. He has visited USA, Japan and Singapore for research activities, and he has strong desire to carry out extensive, elaborate and applied research in the area of biomedical engineering which can benefit the society and improve upon the quality of human life. So such an eminent personality with many academic categories available in front of you. Now I request him to deliver the lecture. Welcome, sir.
Very good morning to all present here. Actually, as Professor Murthy sir told, Professor Rana is supposed to be here. Due to unavoidable circumstances, he said that he will not be available today. So I thought I can discuss some of my knowledge in the field of biomedical instrumentation with all of you. There were many presentations which I have given, but I thought since the audience or the participants are little diversified field, I thought it can be a more of general applications of instrumentation and medical imaging in the field of medicine. I thought that may be more appropriate for all of you when I took this particular topic as my presentation today. So here that medical imaging techniques in therapeutic and surgical procedures. So whenever we talk about medicine, so 3 terms will come into the picture. One is diagnosis, second is pathology, third is the therapy. So what is diagnosis? What is diagnosis means what? Detection. Detection of a particular disease. Okay, identification of a particular disease is what the diagnosis. That is the first stage. Any patient goes to a hospital or a doctor, the first duty of the doctor is to find out what kind of the disease he is suffering from. That is what is called the diagnosis. The second comes the pathology. Okay, so what is pathology?
What kind of bacteria?
Maybe very close answers. To be in a refined way, I can tell. To find the source of disease. What is the cause of the disease? What kind of bacteria, what kind of virus, okay, what kind of malaria parasite has caused such kind of disease? So that is what we call the pathology. Most of that will be carried out in the laboratory test, either by taking the blood sample, urine sample. Many other the tissues can be taken up for this particular purpose to identify and to find the cause of the disease. Now we know what is the disease with the patient. We know what is the cause of the disease. Then what doctor will do? Send home. What next? Next is therapy. That is treatment. So next is the treatment procedure. You start the treatment procedure. That itself we call it as therapy. So whole of the medicine and the biomedical instrumentation goes around this. Either we develop instruments for diagnostic purpose, which can help in the detection of a disease, or we develop certain instruments and procedure which can help and to find the cause of the disease. Once we know both of these, what is the disease and what is the cause of the disease, we see that a patient has to be treated well. And also nowadays a lot of instruments are there for the treatment purpose also. And some of the treatment procedures are going to be through the medications itself, where we give certain kind of medications in the form of a syringe injection or through the oral capsules, by which we can able to overcome the disease. But certain diseases where a kind of intervention is required from the doctor side or the physician side, where he has to carry out the certain surgical procedures on the patient to treat this particular the problem. So under that conditions, so surgery becomes inevitable in certain cases. But again, when you look back from the patient perspective, you suppose if I ask a question, when you suppose you are suffering from a kind of viral fever and you go to your doctor and the doctor says you are suffering from so and so disease, shall I give an injection? Okay, he says I will give an injection by which it will come down. Generally, what is the mentality? Sir, is it okay if you give a tablets? Is it possible? Even though we are so elderly people, even a small syringe we are little bit afraid of that because it will cause a pain, little bit of pain. So which we feel that it is not very comfortable position. Because of that, what we say, sir, is it possible to cure this by medications itself? So in that way, we are going in an advanced stage. Most of the earlier surgical procedures were an invasive procedure, where you have to make an incision on the body. We cut the body tissue, then we enter the body, do the procedure to remove any kind of abnormality or any kind of treatment procedures. So that is completely invasive. And certain procedures are where you need to cut the tissue to the longer extent, maybe a 5 mm, 10 mm or 20 mm or more than that kind of the incision has to be made. At that time also is the unbearable pain, even though if it is might have carried out under general anesthesia or local anesthesia, but after the anesthetic effect, the patient is going to have a lot of pain. So slowly the diversion has come into the minimally invasive surgery, where I can able to make very small incisions by which I can able to carry the surgery. So then the medical people thought, can we have any kind of procedure where we can able to treat the patient without any kind of incision? I want to do a surgery, I wanted to overcome any kind of abnormal tumor in the brain, but I need not to make any incision. Yes, they have put this question to an engineers. Can you come out with any kind of solution where I can able to cure a particular tumor which is there either in the brain or liver or somewhere without cutting the body. Can you imagine? So, but now the tool is available. That is what I want to discuss in this. How the technology has developed from the very invasive procedures to the completely non-invasive procedure. But as the technology proceeds, again there are a lot of pros and cons will be there with any technology. In this work, I want to discuss how medical imaging has helped in doing this particular surgical procedure. That is particularly for the therapy, for the treatment. Next. So this is just I wanted to bring these slides to make it aware. She is a lady. She is a pregnant woman. She has been unnecessarily scanned for CT when she is 3 month pregnant. So what happened is that there was one more patient by the same name called Kerry. They carried by woman 1 supposed to undergo CT. They carried this woman. She is a pregnant woman. But due to the mismatch of the data, she has been sent for the CT scan. So, but fortunate that it doesn't harm her fetus, but she gave a normal birth. This is where it might have went wrong. There is a procedure that might have went wrong because of the same kind of naming of the patient, not maintaining appropriate data of the patient. So, because here the problems are going to be there in the maintenance of the data also, maintenance of the images also. I will show one more image. And this is another boy. He is supposed to be operated on the right eye. He has a moving eyeball. Sometimes what happens, we have the muscles which are going to surrounding the eyeball. If that muscles are not going to be stable, your eyeball is going to keep on shifting left and right without your control. At that he is supposed to be operated on the right eye, but the doctor mistakenly operated on the left eye. Because of that he has a red eye. So this is again a right, it is on the same patient but operating on the wrong side. Operating in the wrong side. What happens, why it might have happened is that when you take any kind of information from the patient side, while recording, you might have entered wrongly. If you have gone to any ophthalmologist, you can see a chart which is exclusive for left eye, there will be one side, one column, right side there will be one more column. Suppose a nurse or a technician enters this data interchangeably, what doctor may not have come to the patient at all. So surgeon will not be in touch with the patient at any time, only his physician will be in touch. Directly patient will come to the surgical room, OT theatre. What he will be having the data? So which one is abnormal? He will see the column, which one is abnormal? Okay, left is abnormal. Okay, but actually in this case, the right is abnormal. He operated on left without looking into them. Okay, so this kind of results, because there is a lack of information, not proper. This is the more fatal kind of thing. What happens? This is a baby. So where there will be two test tubes, there are two catheters which are going to be inserted. One is in the thoracic cavity into the lungs, another is in the abdominal cavity. So in the thoracic cavity, so there is a certain kind of medication which is supposed to be injected. In the abdominal cavity, the food has to be injected. But what happened? While injecting, the nurse has wrongly interpreted, and the food which is supposed to be sent to the abdominal cavity has been sent to the lungs, and the baby has collapsed immediately. So it led to the fetal. So these are all kind of complications we enter when we do certain kind of the medical procedures. That's why there should be an extreme care has to be taken up when you do any kind of intervention on a particular patient. Next. So the medical errors kill more than 250,000 people every year in the United States and injure millions. At all them you have probably a third leading cause of death in the country. It is a statement given by the Dr. Peter. He is one of the noted hospital in the US, the John Hopkins Hospital. But what is the intention is here is that, so sometimes errors may lead to prone to the death of the patient. So operating on the wrong side, operating on the different person for different cause, all these things are the serious errors. Okay. So types of wrong surgery. So this slide I put where surgery may go wrong. Okay, you can just look into this particular point. No. So you can see there is a wrong procedure. Suppose the procedure you have adopted is wrong. Procedure you have adopted is wrong. Okay, there will be different procedure which has to be carried out. Now you have due to the wrong procedure 14%, wrong patient you can see. Operating on X, you have operated on Y for the different cause. Because sometimes what happens, I don't know whether you have seen or not, if you go to any multi-specialty hospital, before the patient enters the surgical ward, OT theatre, there will be one more hall like this. So where all the patients will become and standing in the queue. So they will be standing in the queue one after the other, they will keep on. If that 5 mismatches, so nurse is going to keeping, this is one particular, what is the cradle, this is another cradle, this is. By she takes this and interchange. That's all. This goes with along with that patient. This goes along with, which is interchange. These things are going to happen. At that time, by mistakenly wrong person we are going to operate. That is also another serious cause here. So and other wrong site. This is and the wrong. There are two. One is wrong site location may be different. Another one is going to be wrong site. This is more 47%. You can just imagine 47% is on the wrong side. Why this wrong side happens is that a particular, suppose a patient has to be operated by using an X-ray, something like that. If you observe any X-ray, there will be a proper way X-ray has to be taken, in which they will be mentioning on the X-ray, it will come like this on the X-ray. Suppose if you look, in India it will not carry out systematic way. So on the X-ray it will be either it will come as L or it is coming going to R, something like that. So L stands for the left, R stands for the right. It should be an indicated. But in Indian scenario, some of the people will not carry out this. At that time, they will not be knowing whether it is a right side portion of the X-ray or it is going to be left side portion of the X-ray. At that time, so if the doctor is closely associated with the patient, he knows which side. At that time, he will operate properly. Otherwise, there will be fair chances that he may operate wrong side. So these are the issues. So how best we can able to do? Suppose if you have a particular imaging modality which can able to give a clear-cut information about where is the disease, which side and which side. Okay, who is the patient, which side is affected and which side has been affected. If that information is very clearly available on the image itself, at that time it is quite easy for the doctor to do a surgical procedure. Okay, in that one, so the medical imaging is going ahead, okay, which is going to give clear-cut information when you take an X-ray or if you take an CT or MRI. The information is much clear and says that yes, this is the location, so this is the side where there is an abnormality, which is the side, whether it's the left, right, anterior, posterior, medial, lateral, all these things very clearly it is going to give that information. By that information, the doctor can able to do a better surgery without any mistakes. So in that way, the medical imaging is helping a lot. So I wanted to discuss some of that particular issues here. Next. So that's why this is biomedical engineering is a wide discipline. So what I am looking here is a medical imaging and image processing. But I will not touch upon the image processing because many speakers have already discussed about the image processing. What I will discuss here, how the medical imaging modalities have been improved, which is help in the treatment procedure, that's particularly surgical procedure. So I put just an overall idea about the surgery. Why surgery is required? What is ultimately surgery? So it's a branch of medicine that deals with the physical manipulation of a body structure to diagnose, prevent, cure ailment. Ailment means a disease. Okay. Either you can able to use for the diagnosis purpose. Okay, sometimes you need to do a surgery to find out what is the disease. So sometimes to prevent, for the prevention of any disease to progression, we can able to teach, and for most often it is for the cure. Ultimately, if there is a tumor is there, we will operate to remove that tumor. That is nothing but fully the curing that particular. So who is the surgeon? Who is specialized in the surgery is going to call the surgeon. Okay, so what generally the surgeon is going to experience? The surgeon is going to experience 3 obstacles These are the very important. One is bleeding, second is pain, and third one is infection. So as much as possible, the surgeon see that when he operates, the bleeding has to reduce. Because the blood, one drop of blood is very costly. You will not get as we get a bottle. Okay. So in that way, so as much as possible, the bleeding should be very minimum. The second is the pain. So once the patient undergoes, generally we assume that we do the surgery under the local anesthesia, general anesthesia. But even though we have done under local or general, once that anesthetic effect gets over, he'll have a pain. So if the incision is smaller, so he'll get a little pain. Okay. So in that one, then third one is infection. Suppose you are carried out the surgery. Now, not only that, whatever the wound which has been created has to be minimized. It should be non-infection. So there should not be any kind of infection. There should not be any entry for the bacteria and appropriate medication. So these are the challenges. So these challenges a surgeon has to address. Okay. So advanced medical imaging have transformed surgery from risky art into a specific discipline capable of treating many diseases and conditions. So most of the surgical procedure nowadays based upon this one or the other kind of imaging modality. So that they try to use that particular imaging system which will help during the surgical procedure. That's why the things have become much easier for the surgeon rather than the complicated. As you can see in the first day, Dr. Ravindranath, when he is shown the phacoemulsification. The phacoemulsification is going to see through a particular highly very magnified lens. So where he can able to see the interior in the eye very clearly without much difficulty. So and at the same time, so there will be continuous imaging which is going to come to give a clear cut the image of the internal part of the eye. So by using that particular information, a surgeon can able to do better surgery on the minute or delicate part of the eye. Okay. So next. So how this the surgery concept has started. As you know, Sushruta is the father of the surgery. He started the treatment of this particular by certain methods. He used to cut the certain tissue, start giving the treatment and other procedures. Okay, so that is again the challenges where the bleeding, infection, and the pain. But later, by a particular the doctor that is called the Ambrose Bierce. So in the 1600. Okay, he started treating the particularly the patients or the soldiers who have the gun wounds. So he applied certain modern methods by which he can able to reduce the bleeding. At the same time, he can able to cure the patients at the early stage. I mean, in the sense at a smaller duration. So that's why he is going to be called as the surgeon of the modern medicine. Okay. So next one. And coming to the types of surgery. How the surgical procedures have been divided. One is for the urgency, type of procedure, body system involved, degree of invasive, special instrumentation used. Okay, urgency. So suppose certain conditions, suppose a person has met with an accident, there is a profound bleeding, the certain part of the internal organ has been damaged, immediately has to be taken and need to be operated. That is an urgency. The second is type of procedures that I will discuss one by one. Next slide. So based upon the timing, elective surgery, we call it elective surgery. What is elective surgery? Suppose a patient has a certain kind of problem, but it is not causing major harm. Okay, so he is not affecting his body system at that particular instant or longer period of time. Okay, at that time what he can able to postpone that surgical procedure. Okay, he can get operated after 1 month, 2 months, 1 year, 2 years, like that. So in certain cases, if you look into the newborn babies and other things. So unfortunately, some newborn babies will come with defective heart valves and other things. Okay, but baby will be fine. It will not be having much problem. But the valve there will be some kind of problem. But they may not be appropriate to operate unless until baby is not able to get any kind of side effects. So he is able to do all normal activities. They will not operate. Let us grow. So after 1 year, 2 years, after 5 years or 10 years, they can operate on that particular valve. So that is what is called the elective surgery. It is entirely depends upon the patient request. When he wanted to undergo, according to that, he can able to get it. So emergency surgery, so which must be done promptly to save the life. Okay, if you don't do it, you may not be able to save the life of that particular patient. So and semi-elective surgery must be done to avoid the permanent disability of death. Okay, sometimes you prolong. So it has to be carried out within 1 month or 15 days. Suppose if you progress, no sir, I am not able to get it done within 1 week or other thing, it may lead to certain disability. Okay, some kind of other complications at that time. That is called the semi-elective. It is both sides. The doctor suggests that you have to undergo within a month, within a week, something like that. Patient is not in a position. At that time, it is both pros and cons will be there. Okay, so at that time, appropriate suggestions and guidance will be provided from the surgeon side to undergo the surgery. Based upon its purpose, there are two things. One is called the exploratory, second is called the therapeutic. Is performed to confirm the diagnosis. So exploratory surgery is to suppose, assume that you have diagnosed by certain procedure there is some kind of problem is there, but you are not sure that it is there or not. Okay, you are not 100% confident. At that time, a doctor wanted to explore with further procedure. One example is going to be called the laparoscopy. So particularly it is advised for the woman. Suppose a woman is not able to get conceived for certain problems and other things. They wanted to see internal structure of the abdomen and the uterus. Okay. So at that time, what happens? The laparoscopy is an exploratory kind of surgery. Okay. So it is but a very minor cut, but they are going to see the entire uterus and other the reproductive organs of the female body. So when they put a laparoscope into the female body. So that is an exploratory surgery. Much information is available when you do a laparoscopy system. Okay, it is called an exploratory. Therapeutic surgery, particularly to diagnose and to treat a particular disease. So based upon the type of procedure, amputation, cutting the part of the body to retain the remaining part of the body. Suppose there is a gangrene, something like that. So at that time, if the gangrene is spreading at a faster rate, to save the remainder part of your leg, you have to amputate. You have to cut that particular part of the leg and retain the remaining part. So that is called the amputation. So replenishment involves the reattaching the severed body. A part of the body has been detached, but it has a good amount of circulation. It happens in certain accidents and other things. Suppose an accident has been taken place where there is a sharp knife has cut your finger. If this finger, if you have taken along with the body, and this finger has still good amount of the circulation, the vessels have not collapsed. At that time, what happens? This cut part of the finger is again can be reattached, and they can be able to do that. That's called the replenishment. Reconstructive surgery involves the reconstruction of an injured, mutilated, deformed part of the body. Okay, reconstructive. Suppose there is a deformation, you can able to correct it by this particular procedure. And nowadays it is more popular is another is called the cosmetic surgery. To improve the appearance of the normal structure. So particularly suppose a person is not looking very normal at that time, they can undergo a cosmetic surgery by which their appearance can look better. An example you can take it the Sri Devi and other things where she has undergone a cosmetic surgery to change her nose structure and other things. Many people, particularly in the Western, it is going to be much popular compared to the Indian scenario. Okay, transplant surgery, transplanting one part of the body of a particular donor, okay, to the recipient. It's got to be homogeneous, it may be heterogeneous. So homogeneous from man to man or heterogeneous from animal to man, like that. So depending upon the situation, there is a transplantation. You might have popularly heard about the liver transplantation. So where the liver of one person can be put into the other. So it is or the more popular still is the kidney transplantation. Okay, so that is also requires a kind of surgery. So these are all a type. And body part involved. Okay, which part of the body, whether it is related to the heart, whether it is related to the gastro and the abdomen, whether it is related to your leg, orthopedic surgery, that is called the body part. Degree of invasion, that is called the minimally invasive surgery. Second, where you will have very small kind of incision. Okay, so that is called, as I said, laparoscopic surgery is very minimally invasive surgery. So at just in the abdominal region, just they will make one incision. Below that, another they will make another incision. There will be two incisions only. So where through that they will put a catheter which is mounted with a camera. Okay, so by which they can able to see the internal structure of the abdomen. Okay, so that is called the open surgical procedure. So laparotomy, so and the sternotomy. The sternotomy is nothing but to carry out the open heart surgery. Okay, so they bisect the sternum and open it and have an access to the heart by which they can able to carry out the surgery. Okay. So the by equipment use, whether if you use laser surgery, if you use microscopic kind of things, it is microsurgery. If you use a robot, just imagine, if you use a robot for the surgical procedure, it is called the robotic surgery. I am not talking, it is actual, it is nowadays available. In India itself it is available. Okay, I am not talking anything Western. Okay, so in outskirts of Delhi, it is what is called the Goregaon. So one of that particular hospital has this robotic surgery system. They will do a lot of surgical procedure using the robot itself. That is, they are popularly called the Da Vinci robotic surgical robotic system. And as I was talking in the beginning, so completely non-invasive. Okay, without cutting the body, I can use a gamma rays, which is going to act as like a gamma knife. Okay, by which I can able to cut or remove a part of the tumor and something. Those are called the gamma knife surgery. They are completely non-invasive procedure. We will not going to cut or we will not going to make any incision. Okay, so this. So just as I was talking. So here, suppose here, if you look into this is the open heart surgery. Suppose you wanted to carry out an open heart surgery. So sternotomy is going to call the sternum. So this is the sternum. So that is going to be called the flat part of your bone here. So where you need to make a section has to be cut. So so that they make, you can see the amount of incision which is going to come here. A lot of, you need to completely cut this and then they will open this, get an excision for your heart, then operate on the heart. Okay. But nowadays, if you go for robotic surgery, okay, so that is going to call the Da Vinci bypass incision. Just you can have 3 incisions. Between the ribs, we have a space, okay, which is going to call the intercostal space. So they will pull that ribs, make a little bit space, then make a small incision through which robotic arms will enter. Okay, the robotic arms will enter. I will show a video. So at that time you can see the imagine what is the amount of incision you are making here, what is the amount of the incision you are making here. It is almost like a keyhole surgery. Just like a key and get an excision to this door. What you do, if you open it, put a key and open it, it is an excision for the whole of that particular room. Similarly, what we need, an entry. Okay, we have mechanism to see inside. We have the advanced cameras which can have a better focusing to see what is there inside. What is I need is put a camera inside. Once camera goes, it will give what I need ultimately, see what is there inside. How best I can able to see. Now we have very high resolution cameras, okay, which is going to give very clear information about what is there inside. Okay, so that kind of things are going to be there. So this is I am showing a detailed view. This is how earlier the surgical exposure of the heart for the midline sternotomy procedure. Okay, just make an incision, open it like so, then you have an incision, then so operate on this. So this is going to be certain places. Still it is also a procedure commonly used, but slowly we are shifting to the minimally invasive where you can able to enter between the ribs. Okay, because the heart will be here, just you can able to pull the ribs little bit and make an entry. You can able to get excision to your heart. So that's why they are going to call it keyhole surgery. Okay. Next. So operation phobia. What is operation phobia? Once, if I say you have to undergo a surgery, the patient start thinking multiple thinking start. Okay. Patient concern. Will I wake up after the operation? How many times it will happen? Whether I will survive? First question comes, whether I will survive. Okay, because it is a natural phenomenon, because anybody will afraid of any kind of surgical procedure. How much pain there will be? Okay, whether it is going to be huge pain and other things. When I will be able to back to the work. Nowadays we think, majority of the working people, we think about this. So how many days I need to be bedridden? When can I go back and resume the work? All those things. How long it will take my incision to heal, and what will this scar be like that? Whether suppose you are undergoing any kind of surgery near to your face and other thing, whether it will make any scar, whether that scar will be permanent. Okay, all these things will come into the picture. Okay, so we look multi-way. Okay, so from survival from the cosmetic point of view also. Okay, so in that one, so these are the okay, and also the demands will be these concerned demands are focused on the comfort. So whether you will be comfortable after the surgery, cosmetics, rehabilitation, how fast I will come back to work, which are all affected to the degree of invasiveness. That is very important. So how much you are going to invade the system, that much problem you are going to have. Suppose you are going to invade the system to the greater extent, naturally more pain, more time on the bed, more cost, everything will be high. Suppose the degree of invasive is going to be lesser, cost will going to be come down also, the amount of the pain will also reduce, and you can go back to work at the faster time. Okay, so that's why what we are looking in the nowadays in the biomedical side towards the medical surgery is minimally invasive service. Okay, minimally invasive service. We need to invade the system as much minimum possible, or non-invasive surgery, completely non-invasive. Okay, but certain cases where we cannot able to make non-invasive, we have to go for the invasive, but make it small. That is what we want. Next one. Okay. So one among them now is which is gone into the with intervention, with the involvement of medical imaging system. That is why for the interventional radiology. Okay, so which is going to call popular for the IR. It is also part of the vascular and interventional radiology. So because from the surgical point of view, they are going for the VIR. Okay, so that is for the vascular interventional. Because here in the interventional radiology, so we look the vessels through an imaging system. Okay, so this becomes a minimally invasive image guided procedure, where a streaming video will help the surgeon to do a surgical procedure. Okay, so that is what is going to be for the image guided procedure. Okay, so because someone has to show the path where I need to operate. Okay, where is the infection, where is the problem, and how to approach that particular region. If I know that, the surgeon can able to do better. Okay, so that way, so the concept behind IR is to diagnose and treat patients using least invasive techniques currently available in order to minimize risk to the patient and improve health outcomes. So the patient will going to recover very fast. So interventional radiologists pioneered modern minimally invasive medicine such as angioplasty, catheter, delivered, stent, etc. For that one, they use X-rays, CT, ultrasound, MRI machines, by which they can get a better images, so which will help in making the surgery in a better way. Next. So what interventional radio helps? So physical trauma, so very minimum physical trauma means very less kind of incision. Reduce infection rates because the wound is small. If the wound is larger, chances for infection is going to more. If the wound is less, chances for infection is less. Recovery time is going to be less. Shorten hospital stays because the incision is very small. Okay. So he is the Dr. Charles. So he is the one who has called as the father of interventional radiology, who started this procedure of using an advanced X-ray machine, that is what we call the fluoroscopy system, for doing the interventional radiology. Okay, so that is he was also nominated for the Nobel Prize in 1978 itself. So one among them, which is very popularly image-guided surgery, okay, is going to call the angiography, and subsequently an angioplasty. Okay, majority of you might have heard or you might know about what you mean by angiography and angioplasty. So angiography and angioplasty will be done under a imaging system, for which we need an advanced imaging system, which is an extension of X-ray machine. An X-ray machine which is provided with a fluoroscopy system is become a tool to do angiogram. Okay. An estimated 3 million coronary angiograms are performed in the United States every year. Okay. So worldwide 7 million angiograms are performed each year. You can just imagine what is the amount. So this is in Indian scenario, the number of the coronary interventions angiography which have been performed. I had a data up to 2007. You can see it is keep on increasing every year. Here the amounts are keep on increasing, and subsequently if you have performed an angiography and you feel that there should be a stent has to be placed. Okay, so at that time you can see the number of stents which are keep on placing is also being increased. Means the number of people suffering from this kind of problem particularly the blockage in the heart, in the coronary arteries and other things is increasing, for which we need to have a better procedure to find out where is the blockages and how best we can able to overcome that particular blockages. So this is an angiogram, how it looks like. Angio, okay, gram. Angio means vessel. In medical term, angio means vessel, gram means a kind of display. So angiogram is going to give a display of a particular blood vessel. Okay. So here, this is the first angiogram. Immediately after the Röntgen, okay, so he is the father of the X-ray, who is invented X-ray. Immediately after that, this is the first angiograms have been taken. Okay, so which is going to see how the blood vessels, you can able to see very clearly blood vessels. So if there is any kind of blockages are there, they can able to check. So this is the first angiogram which is used, and this is as I said, immediately only after few months of invention of the X-ray, they have taken this particular angiogram. That has motivated the people to use X-ray for the better use in the medical field. So what actually angiography requires? An angiography requires an advanced version of an X-ray system. That is generally we more popularly called CR. Okay, so this you can see this is called CR. So what an angiography system consisting of is an X-ray tube, an image intensifier system. There is a video here, okay, video camera. So ultimately what happens, patient will be lying here. So then the X-ray will be passed. For an X-ray, the whole body is going to be act as a transparent. So whatever it's going to receive, it goes through this image intensifier system, and that whatever the body parts which are being seen are going to be recorded, and through the video camera, it is directly connected to a display system where you can able to get. So this is how actual system looks like. So here you have an X-ray tube which is inside, and here you have the image intensifier. That is what is called the fluoroscopic system. So this is the bed where the patient is going to lie, and all this is system connected. You can have a monitor here where you can able to see the display of the part of the body or the part of the vessels, okay, which you are going to visualize. So this is simultaneous orthogonal. There are two ways. One is called the uniplanar, the second is called the biplanar. If you are looking only one plane, only one direction, that is going to be uniplanar CR. But sometimes we want an two-way view. At that time we go for the biplanar. So this is at that time we need two systems. So here one X-ray tube. So and there is one detector system, and again we have one more this system here, which is going to be perpendicular to each other. Okay, and they will be giving the information parallelly, and the doctor is going to see in two views. So one is maybe the frontal, okay, another may be sagittal side view. At that time we can get a clear picture about where is that vessel, where is the location of the vessel, what depth, all information is going to be provided. Okay, so that's why we use biplanar, which is going to be costly as we will go, and it will have 6 degrees of freedom. 6 degrees of freedom means we have generally 3 degrees of freedom, X, Y, Z. Okay, now we have two things, two X-ray tubes, two image intensifier. So that will be 6 degrees of freedom. So in that one, so you can able to view a particular object in 6 waves. Okay, so in that way, that is going to be advantageous. So that is an auto injector. If you come yesterday into the CT room in the SS hospital, they have shown this an auto injector. What is this? I will explain that auto injector mechanism next. So this is how a angiography system is going to work. So as I said, this is X-ray tube. So here an image intensifier. What is the difference? You may have a question. What is the difference between an X-ray system and advanced kind of what is called as the fluoroscopic system? In X-ray system, what happens? When the X-ray passes through the human body, which is going to be in the form of a photon energy, directly hit the film, and that film, which is going to get that particular photon energy, makes that particular film black and white depending upon the amount of the photon energy falling. Okay, directly light is going to fall, that is photon energy is going to fall on the X-ray film, by which developing we will get the contrast, where is the bone, where is the soft tissue and everything. But here what we do is we will use a kind of system that is going to be the image intensifier system. What will have a phosphor screen. So when the X-rays are going to hit this phosphor screen, they convert that light energy into electronic energy. That electron energy is going to be travel towards the other side, which is going to be, and it becomes a stream of electrons. The stream of electrons is going to carry, again we have one more window here, the output phosphor. That output for the electrons are going to hit that particular phosphor again. That electronic energy is converted to light energy. This light energy is captured by your video camera. So what that information is coming is about the internal tissue structure of that particular part of the body. Okay, suppose there is a bone is there is surrounding soft tissue is there. This bone is going to absorb more energy. Okay, so and less energy will come out from this. If surrounding soft tissue is there, so less absorption, more transmission. Because of that, the amount of the photons coming varies from position to position, and the amount of the electrons emitted varies. Amount of the light coming is also varies. We are going to project on that information on a two-dimensional screen that is going to give clearly where is the bone, where is the soft tissue, where is the blood vessel and other things. Okay, so that is the development further. That is X-ray converted into the fluoroscope. X-ray is going to give still image. A fluoroscopic system, that is an angiographic system, is going to give a continuous image. Okay, so in a video. So next. So this is how it will happen. So what is the mechanism we will adopt in the angiography? So this is what we do is, suppose you wanted to suppose a person is suffering from a heart block in the coronary artery. The coronary artery is the one which is going to supply blood to the heart muscles. Okay, so if there is any blockage in the coronary arteries, the heart muscles will not get sufficient blood. So if they don't get sufficient blood, they may not be able to contract, and your contraction of the heart chambers will reduce. That may lead to certain subsequent consequences. Sometimes you might have heard about the heart attack. What is ultimately heart attack? There are two coronary arteries. One goes towards the right of the heart, another goes to the left side. So if there is a major one which is going to the left ventricle, if that is completely blocked, left ventricle will not receive any supply. If there is not going to any supply, so what happens? It will not able to pump, and immediately the left ventricle is going to collapse. If the ventricle is going to collapse, there is no blood which is coming out from the heart. If there is no blood is coming out, no blood supply to the brain. If the brain does not receive blood supply for 5 to 6 seconds, okay, so the brain activity start coming down. So these are the subsequent consequences of improper blood supply to the heart itself. Even though heart is an organ which is supplying blood, or it is supply or pump the blood to the whole of the body, it requires blood supply for its own work. Okay, so the heart muscles require blood supply for that is supplied for the coronary arteries. So what we do? So suppose there is a blockage. You might have heard about a person has an heart attack, but he survived. What do you mean by that? So there is a minor blockage, may not be major blockage. So at that time, what happens? Immediately there is suggest for an angiography. What they do in angiography? So this is the mechanism. They put the patient under the angiography system. Okay. So what we do is first we take an image which is putting without any what is called as the dye. Okay. Without putting any dye, we will take a particular image. Next, what we do is as a blood vessel and blood for an X-ray is a transparent. It will not going to give any kind of, suppose if I take an X-ray and we will not able to see any blood vessel because it is almost transparent. So to visualize that particular blood vessel, what has to be done is that we need to create a contrast mechanism. What we do is, as I said in the previous case, can we go back to the previous slide? Yeah, we use this auto injector. So we fill a kind of dye which is called the cardiogram. Okay, so when it goes into the bloodstream through a catheter, we will insert that and it goes and we inject that particular cardiogram, which is a completely non-toxic kind of the solution. When it goes to the and mixes with the blood contrasts it. It is as good as putting a drop of ink in the water. Suppose if the pure water is there, you will not able to see. Suppose if I put a drop of ink, you will start seeing that water. So what happens when you put the dye? So you start seeing the blood, how it is. Simultaneously, I will pass the X-ray and see light rays is coming. I will capture that image through a video. That video start appearing on the screen. Okay, by which I can able to see how the blood is flowing into the arteries. So next, this is how it happens. So this is an actual mask image, actual angiographic image, so which is after injecting a dye. What we do is we subtract this from this. Okay. So what happens? This is actual without putting any dye. Now we have put a dye and taken an image. Then we subtract. Then what we will do is, what additional information I have here is the blood vessels which are injected into the dye. At that time, what I will do is, so I will give only the blood vessels. So this blood vessel is what is called the angiogram. This is what we are going to see ultimately. So you can see a better view. This is the original image. So without injecting any dye. So after the injecting the dye, you can see see here. Can you see any blood vessel here? You will not see. Now you are able to see the blood vessel. But what is the problem here? So bone also you are able to see. Okay, some other substance we are seeing, which is going to disturb a surgeon. You may not be able to get the clear information. What we do? We subtract this information from this. So at that time, what I get? Only blood vessel. So that is going to give clear information where the blood is flowing, how the blood is flowing. Okay, so that is what is called the digital subtraction angiography, which is the latest. Okay, which is going to be current trend in the medical imaging system. So this is how things have happened. It is little advanced level. So step 1, step mask images, digital subtraction angiography, reconstruction. Suppose you wanted to visualize in 3D. What you do is, instead of using ordinary X-ray fluoroscopy, what you do is use CT machine. Do the same process. Instead of taking one set of, you take multiple slices, okay, and reconstruct it. At that time, I see how best I can able to see these blood vessels. Even nowadays, you can able to color that particular part. So where the blood is flowing, how best it is going that. So this information is quite useful for the surgeon to find out where is the vessel, how best blood is flowing in that particular vessel, is there any blockage in that particular vessel. Okay, so that is the way information is going to be quite useful. Next. So angioplasty. Now what has been done is that you know that there is a blockage is there. Suppose there is a blockage is there, and you know through the angiography there is a block. But what you do, you need to go for the overcoming that particular blockage. So that is what is called the angioplasty. Is a technique of mechanically widening narrowed or obstructed arteries as a result of atherosclerosis. What is atherosclerosis? It is nothing but a fat deposition in your artery. Okay. So sometimes what happens? So there will be undigested food and other things. It is going to be highly calorific and other things start depositing in the certain arteries. The major artery is going to be coronary artery. If it start depositing in the coronary artery, it start blocking. So the blood is not able to flow easily. At certain extent, it happens that this blockage is going to become major. So if it becomes major, there will not be much blood supply to your heart muscle system. At that time, heart is not able to pump properly. Okay. So at that time, what happens? We need to clear that particular blockage. That procedure of clearing that particular blockage is known for the angioplasty. I will show that diagram. So this is a kind of, see, as I said, I am showing a part of your coronary artery. This is what is called the plaque. See, this is the deposition. So due to this, what happens? Your arteries, coronary arteries has become narrow. The amount of the blood which is going to the heart muscle is getting reduced. So this is the how the deposition will be there. You can see the amount of the deposition. But how to overcome that? Okay, suppose if there is going to be a minor deposition and other things, what we do is we need to press that particular, we need to expand that particular arteries. What is the mechanism has been done? We pass a catheter. First we will insert a guide wire. Okay, that we will see whole process is taken under the angiography system. There will be X-ray system, there will be continuous monitoring. We insert a guide wire through one of the veins. Okay, that it goes all the way and enters into the heart. Then we pass a catheter into that. Then it goes and sits into particular coronary artery. Now we are able to see that where that particular catheter is going, where that guide wire is going through your monitor. Then once we see that location, at the tip of that particular catheter, we will insert a balloon. Okay. Then once the balloon goes and sits there, we start the inflating that. So once you start inflating, you can see this particular the plaque, which is very thick. Okay, it is almost more than 50%. Will press to the wall of the artery. By pressing that, what happens? The amount of the blood which is flowing here is increases. Once it is increases, the blood supply, if it's much higher, it starts removing this particular block. So it is as good as suppose there is small pieces of the stones or something in a channel, the pressure is more, it will clear that particular dust particle. Suppose if there is a dust particle is there, if the amount of the water flowing in that channel is less, it will not able to clear that dust. It is as good as your charandiಗಳು ಮನೆ ಅದರ ಚರಂಡಿ ಇದೆ, ಈಗ ಮಳೆ ಬರ್ತಾ ಇದೆ, ಸಾವಕಾಶ ಮಳೆ ಬರ್ತಾ ಇದೆ, so it will not clear out that particular charandi. If rain comes heavily with high force, all it will fill and all that charandi will be clear because the amount of the force. So here sometimes what happens, due to that force, this plate will get washed out. But unfortunately, in certain cases, it will not happen. There is a fair chance that this again may come back. Okay, it may again pull it and other things. So what is required? Some support to keep wider. It has to kept open only. At that what we do is we extend that with a stunt. That is what is called the coronary stunt. So it is a metallic, a hollow ring. Okay, it is a metallic hollow ring which is going to be a biocompatible material. So what we do is we put at the tip of the balloon. Okay, it goes like this. Then what we do is we inflate the balloon. As we inflate the balloon, that particular ring also expand. Once it is expanded, it holds that artery. Artery is narrow. Now it is expanding. It holds. It is going to become bigger. Okay, then we remove that. We remove the balloon by deflating, and the stunt will be held like this. Okay, once the stunt is held like again, normal flow is going to take place. Plate will be here only. It will not be completely washed out. But subsequently, certain medications and other things you can able to clear that. But the one more problem, what generally what happens sometimes, this plate is very advanced stage, either by the angioplasty, balloon angioplasty, or by stunt. You may not able to. Doctor comes to conclusion you may not able to clear it. At that what happens, only solution is the bypass. Okay, so they do for the bypass surgery. The whole bypass surgery is again carried out under the angiography system. Okay. So just click on that video. Just go ahead. Click on that icon. Okay. Okay, sir. Okay, just say it. Supporting.
Your heart is a beating muscle that pumps blood continuously. In a healthy person, the inner walls are smooth and uniform in thickness, allowing red and white blood cells and other components of blood to flow freely through arteries, your heart,
You can see whole phenomenon how it
our
happens.
body. Over time, however, a high level of circulating cholesterol can cause fatty deposits to build up. These deposits, called plaque, can harden and cause narrowing of the inside channel of the artery, a condition called atherosclerosis. If atherosclerosis develops in the coronary arteries, the condition is known as coronary heart disease, or CHD. Patient services will direct you to the cardiac ward or day of surgery admissions area. A general admissions process will follow, or may have already taken place as a pre-admission process. A full history will be taken and bloods analysis and ECG will be performed. It is likely that an IV cannula will be inserted in your arm. You will then be prepared for your procedure. An orderly will escort you to the cardiac cath lab, where you will be asked to verify your consent and confirm your paperwork. The check-in nurse will then shave your groin or arm, depending on the point of access chosen by the cardiologist. You will now enter the cardiac cath lab. The nurses may use an airbed to gently move you onto the operating table. From here, 2 nurses and a cardiologist will look after you, while a cardiac technologist and a radiographer monitor you from an observation room. The camera sitting above and below you will rotate, ensure that your arteries are captured from all angles. During the procedure, you may be directed to take deep breaths and hold them for a few moments. This allows the cardiologist to capture a clear picture of the coronary arteries. During the diagnostic procedure, the lights will go on and off. This is normal and allows the cardiologists to see the images.
Now they are going to insert the catheter.
It is important to lay still with your hands by your sides throughout this procedure, unless the cardiologist directs you otherwise. After the nurse has draped you for the procedure, the cardiologist will numb the point of access with a local anaesthetic. Once the local anaesthetic has taken effect, a small tube or sheath will be inserted into the artery, either in your groin or arm. Once the sheet is in place,
This is what
the
is called a guide
cardiologist
wire.
can then pass the catheters up to the heart. An iodine-based solution is then injected through the catheters, making the heart's coronary arteries visible and allowing for X-ray pictures to be taken as the solution flows through the arteries.
That is the what is called this here. They can able to position in any particular direction. This is mounted in the fluoroscopy system with a camera.
The cardiologist will also take a picture of the left ventricle, which is the heart's main.
This is the auto injector, what I say.
For this image, a slightly larger amount of dye is required. This can often cause a hot flush sensation that can last for 5 to 10 seconds. This sensation can be felt in your face and throughout the rest of your body.
This is
essentially wherever your blood flow carries the dye. It can sometimes also make you feel like you're passing water, but rest assured that this is just a sensation and you will not wet yourself.
The whole system will give the guidance where the guide wire is going, where catheter is going. Okay, so it will be completely monitored. You can see this is the catheter. From this one they start putting the dye later.
Once the angiogram procedure is complete, the cardiologist will advise if you need an angioplasty and stent. This procedure is called a percutaneous coronary intervention and will be explained in more detail shortly. The cardiologist will have discussed this possibility with you prior to the angiogram procedure.
Process is over now. Now they visualize
but not always,
the video and the subsequent images to find out where is the blockage and what is the problem. So simple, very systematically with a minimal invasive. That is possible because we can able to have a kind of imaging modality.
Involves the use
Now it starts. The rest of the process starts with the
artery
technician.
passage. The cardiologist will pass an extremely fine wire down the length of the coronary
You can see
artery.
the animation.
He or she will then pass a catheter with a small balloon built into its tip along the wire to the point of the artery where the narrowing
This
is
is the
developed.
blockage.
The balloon is then inflated, pushing the plug
What I said, the balloon
away
injector.
towards the artery walls, widening the passage through.
So passage has been widened now. See, now we can able to see.
Cardiologist may also insert a stent, a
This is the mechanism of insertion of stent.
made out of metal mesh, which is permanently embedded into the artery wall.
This is the stent.
Hold
That
that
will be
part
there.
of the artery open.
See, this is what it is. And
During this
you can able to see whether the blood is
may
flowing
ask
properly.
questions such as, are you comfortable, or do you have chest pain? This is because a percutaneous coronary intervention can cause a similar sensation to that of angina or chest discomfort. If you do experience any discomfort, staff may ease this with medication or oxygen. At the end of the procedure, a sheet or tube will be left in the femoral or radial artery. This will be removed by a nurse either in the recovery area immediately after your procedure or at a later time, usually 3 to 6 hours later, while you're in coronary care. It is very important to lie still after the procedure. So
once angiogram has been done, next process starts, whether it has to be angioplasty has to be carried out, or stent has to be placed, whether bypass has to be carried out. That will be decision.
During your recovery, your cardiologist will review the images of your heart and will discuss the results with you and outline any ongoing treatment you may need. It is to take your managed symptoms to be able.
So this is all possible because of the advancement happening in the field of medical imaging. Okay, just earlier we had only an X-ray system which is used to give still images. Now we have a digital subtraction angiography which is going to give a continuous stream of image and other things. So that will be quite helpful in doing a surgical procedure in a simple way, in a systematic way, without any invading much of the body tissue. So next one is called the image guided surgery, which is also called the stereotactic surgery, where a set of images will help you, assist you in guiding how surgery has to be carried out. Since time is little less, I will put my slide a little faster and cover major parts of this particular presentation. Okay, just you can go next. I will explain what are the steps here just by some images. See, this is what whole concept of image guided surgery. So where will either they take up help of a CT or MRI. So and we put a certain kind of this stereotactic frame. So it is going to be called the frame. We will fix the frame to the patient cranium system, that is the head. With fixing the frame, we take a set of the images from CT or MRI. So the CT and MRI will get the multiple slices in all the 3 directions, X, Y and Z. That means frontal, okay, sagittal, side view and horizontal, transfer view. So you can see, okay, you are seeing this particular part of the body in all the 3 directions. Okay. So once you have all these 3 slices and the multiple slices, if you club them, you will get a 3D view. That is what we call 3D reconstruction. Okay. Once you have a 3D reconstruction, we have anatomical markings here, which is going to be having anatomical markings. So based upon the anatomical markings, so if you are able to see where is the position of a tumor, okay, so I can able to see, because I know from, suppose if you consider this is the frontal image, this is going to be sagittal. So from the front, how the tumor is from X plane, how much it is above, from Y, how much is behind, how much is up or how much is below. So I can able to locate a point from all the 3, from X, Y and Z, by which I can able to get precisely the location of the tumor. Once I know the location, what is required is to reach that particular the tumor. So at that time what happens? So you can able to get an imaging structure like this, which is going to give a virtual image. This is a virtual image for a surgeon, which gives an idea where is the location of a tumor or abnormality. So he has a virtual concept where the abnormality is there. So then it becomes easy. So this frame will also have a particular the support for the passing the needles. So by which you can able to carry out the surgical procedure. So what they do is, you can see this is the best way. Next one. So this is the how you can able to reach a particular. So this is the image guided surgery, which is going to give information in all the 3 directions. So once you have the 3-dimensional information, so I can able to pass my needle exactly from X position, how much depth it has to go, from Y, how much distance, and Z from how much distance. So exactly I will go and reach that particular tumor site. Then I insert my tool, either a small cutting tool, by which I can make a small incision. Okay, you need earlier were the days where if you wanted to perform some kind of surgery on the cranium, on the brain, you need to open the skull and perform the surgery. Nowadays, there is no chance of opening the skull at all. Okay, so by this, if you go back, so this needle, here we are going to put a particular needle which makes a keyhole, a small hole, and through which we will pass a catheter. Along with that, a camera will go and tool will also. The camera is going to give image and tool will perform the incisions. Okay, it will make a cutting operation. So that is going to what is called the stereotactic surgery. Okay, so that is going to be an advancement which is possible only with the support of CT and MRI, which is going to give 2D slices, so which can be used for reconstruction of the 3D. So this you can see how we can able to see. I can able to see this. This is a part of the tumor. So these are the part of the brain. I can able to locate exactly where is the portion and enter the tool. And on the screen, the doctor is going to get where my tool is moving. Okay, so by which he can able to precisely move to that particular location to make a particular incision or cut on that particular the tumor. So the gamma knife surgery, as such, gamma is a ray, but we are using gamma knife. The reason behind that, the gamma ray is used to remove that particular tumor, not by cutting, by burning kind of things, by which the progress or the cessation of that particular tissue growth is going to stop. Okay, that's why we got the gamma knife surgery. As highly focused gamma rays are aiming at a target region for treating a small to medium sized intracranial lesions of the tumor. Okay, so generally this the gamma knife surgery setup will have cobalt 60 sources, which is going to generate the gamma rays. So which will be built in a particular gantry. Okay, so in that one the gamma rays is going to be focused, and we are going to focus that particular gamma ray to a particular the location itself. So by passing the gamma rays, so we can able to clear that particular tumor. Here we are not making cutting that particular tumor, rather that we are going to passing the gamma rays, make that particular tissue or the tumor inactive. Okay, so that is how we can able to cure. I will show that some pictures by which you can able to understand. So this is next one. So what actually it includes is a head frame. So what we do is we put a head frame to a patient and take a set of the images using CT and MRI. Okay, so this is the head frame, how it is going to fix. It is going to give a landmark positions on the head, which is going to act as a reference. Okay, which is going to act as a reference. Then, so once you put the head frame, what we do with the head frame, I will take the multiple slices of the brain. That slices information will come like this. Okay, so this is one slice I am showing the MRI scan of the head with a frame. You can see the frame has been connected only to the certain points on your this curve here and here. That markings you are going to get here. Okay, so like this is one slice. We will get a multiple slices there. Once we put all the multiple slices together, it will give a 3D. Again we will get a 3D. So once we get a 3D, it will also give, if there is any abnormality, that particular tissue will also start appearing in that particular 3D. Okay, this is the next. See, this is how it happens. So ultimately, once we will get, so we can able to locate where is the location in all the three directions, all the three planes, frontal, sagittal, coronal, all the horizontal transverse plane. So that is the location, and also the doctor can able to make an appropriate assessment. What is the size of that particular tumor? Okay, what is the size of that also can be made. Then once you know the landmarking of that frame, and you know where is that tumor. Okay, so then what is the required is you need to focus the gamma rays to that particular location itself. So what we do is we will adjust the whole gantry system. Next. So this is what is called as the helmet. So this is it is not connected directly to the patient the head, but is little away from that. So this helmet has a small holes. Through that the gamma rays is going to connect it. This is the gamma ray generator. Okay, this is the gamma ray generator which is going to emit the gamma rays. Through that particular gamma rays, so through these holes, the gamma ray enters, and you can able to focus all the gamma rays to one particular location. Next. So this is how it happens. See, so the patient goes here with frame and with this particular helmet. Gamma head frame with the helmet. So you can see this is a smaller holes. So all have a common focal point. Okay, the focal point is common for all these particular holes because they are in the dome shape. Okay, when you pass one ray, it will also focus to one point. If you pass another ray in another direction, all of them is going to focus to one particular point itself. Okay. So that is once we know where is the position, then we put this particular helmet, then pass the patient into the gamma ray generator. So this is the gamma ray generator. The patient goes here. So then we start the system, the gamma rays are going to emit it and it will focus on that particular tumor itself. Once it is going to focus on that particular tumor, so the progress of that particular tumor will be, we are going to, what we can able to in a rough way, if I say, we will burn that particular tumor, okay, by injecting the gamma ray. So by which the tissue, the abnormal tissue death occurs. So once the tissue death occurs, the body has its own mechanism to remove the debris. Debris means what we do, suppose you are constructing a house, there will be some debris, we put the workman to remove the debris. Here the debris is our body fluids, the workman is our body blood itself. So when the unwanted material is there in the body, so what happens, the blood is going to start removing that unwanted material and it is going to be exuded from the material. That is how the tumor is going to be removed. So here it is a completely non-invasive surgical procedure, it is a surgery. But what we have done, we have not cut any part of the body. Okay, what we made, we use the gamma rays to focus that gamma rays on a particular tumor. So by which the tumor progress and the tumor, what is multiplication is going to stop, and the ultimately tumor is going to die. Okay, and it's going to, body is going to exit that particular, the debris of that particular tumor. So this is the focusing, how it happens. This is the mechanism of the next one. This is what happens. So this is the helmet part. So it has a collimator. This is the target. So these are the all the gamma knife surgery system itself. It has a cobalt 60 source which is going to emit the gamma ray. So we focus that through the collimator system onto the particular area. Because why we able to have, we have landmarks from the frame. From MRI we have the 3D information which is going to locate the tumor. What we ultimately require is to focus it. Okay, so by using this particular, we are exactly focused where the tumor is there and we are going to kill that particular tumor. Just click on that or go back. Just not that. Bottom. Gamma knife surgery here. Just 5 minutes. Wind up. Full volume.
Gamma knife surgery. From the patient's perspective.
This is all possible by medical imaging.
And what you as a patient
have CT, MRI, fluoroscopy, all those things, these are possible. If you don't have imaging system, this is highly impossible.
Used to treat selected neurological diseases. Like cell gamma knife
completely non-invasive.
In the normal sense of the word.
Immediately after this surgery, you can go.
Incisions. Instead,
there is no kind of what is you can say rest days or how many days you should be there in the hospital.
The treatment is painless and also allows the patient to quickly return to normal routines. More than 50,000 patients undergo gamma knife surgery every year. The method has been in clinical use since 1968. And there are more than 250 Lexel gamma knife systems in operation around the world. Gamma knife surgery is a unique method that delivers extremely focused radiation beams to the target in the brain. The patient's head is positioned inside the radiation unit.
This is all adjustable.
During treatment, all radiation beams meet in a focal
point. By adjusting that, I can able to focus. I can able to move the patient. I move the collimators. By which I can able to focus.
Healthy tissue on their way to the target.
I can able to move the patient.
But very powerful when they simultaneously merge at a single focal point. This can be compared with the principle of a magnifying glass in the sun.
See, they are burning
there. Small pre-programmed movements of the head into different positions. The shape and dose of radiation is optimized to affect only the target, without damaging the surrounding healthy tissue. In most cases, a single treatment will be given. This will involve 4 main steps: attaching the frame, imaging, treatment planning, and the treatment itself. A specialized team takes care of you throughout the entire procedure, and the patient is, in most cases, awake at all times. Before treatment, the doctor will inform you about the whole procedure. To begin with,
Making
the
awareness of
lightweight
the
frame
procedure to
will
the
be
patient.
placed on your head. Hair
This is
doesn't need to
important.
be cut
Fixing the
or
frame,
shaved.
getting the landmarks,
Local anesthetic
reference.
is applied where the frame is to be attached. Once the anesthetic has taken effect, the frame will be fixed to the head with 4 pins. The frame remains on your head throughout the entire procedure to keep the head in a stable position during imaging and treatment. Attaching the frame takes about 15 minutes. A coordinate box is used during imaging to provide reference points on the images for the treatment plan. After the head frame is in place, it's time for imaging. For example, MRI, CT, or angiography.
Anything. You can use MRI or MCT.
Although these imaging studies may have been done before,
Best is the MRI,
they
which
need
is
to be
going to
done
give
again
much
with the frame
soft tissue
on
contrast.
to determine the exact location, size, and shape
Imaging is
of the
over.
target.
They got the
After
slices.
imaging, the
They
coordinate
see
box
on
is
the
removed.
console where is the slices, where is
The images are now
Now
transferred to the sophisticated
he
treatment
is the
planning
surgeon.
computer.
He is the who is going to be.
Once the images have been taken, you can rest, while the doctor, often together with another specialist, develops your treatment plan. Each treatment plan is unique and individually designed to address the particular patient's medical condition.
They are locating.
The specially designed treatment planning software assists the doctor in preparing the treatment. For added security, the final plan is rechecked and approved.
Where is the
Once
location?
the treatment plan
What is the amount of dose has to be
the
given?
actual treatment can begin.
And,
Before starting,
What is the angle
doctor
of
will
focusing?
explain
All the
how
details
long
that
the
you will
treatment
then
will take. You will lie down on the treatment couch, and the head frame will be attached to the patient positioning system,
now they will go to
which
the
automatically moves the head
gamma
during treatment.
machine, over 60
The
machine.
number of small movements depends on the shape and location of the target. The treatment is silent and totally painless, and will last a few minutes to more than an hour, depending on the target. During treatment, you will be fully awake and able to communicate with the doctor and nurse through an audio-video connection. The team is there at all times to assist you. Once treatment is complete, the frame will be removed.
Surgery is over.
Some patients may experience a mild headache or minor
Single
swelling
shot.
where the frame was attached.
If you
but
have
most
multiple
report no
lesions,
problems.
multiple positioning may be
The doctor
required.
will inform you whether or not an overnight stay is needed for observation, or if you can go home immediately. Either way, a patient should be able to return to a normal routine
No
in
need
a
to
day.
overnight stay, nothing. All these things
The
are possible.
doctor
It
will
is
stay in contact with you
now
for
reality. It
periodic
is not just a
follow-ups
virtual
and
thing. It is
consultations.
now reality. Many people are undergoing, and it is an advanced stage of
over time.
and it is more going to be more precise, more accurate compared to the manual kind of
which means that the
procedure. It is
result
going
will
to
be
be
seen after a
much
period of
complicated.
weeks or even months.
They can have a continuous a weekly discussion with their
Gamma
physician and
surgery
other
is a
things.
well-established
See that there is not
non-invasive
much
treatment
progress. They can have
which allows the
after
patient
1 month or 2
to
months,
return to
one or
normal
two
routines.
scanning by which they can
Guiding
confirm whether there is
principles of
any
gamma surgery
complete
are
cessation has
and
taken
will
place or
always
any
be
regrowth has been
clinical
taken.
effectiveness
All they
and
can able
patient
to
comfort.
promote. So the advancement which have been taken place. The one more is left out, that is robotic surgery, where I just play the video, maybe you will understand. So where, why this robotic surgery has come into the picture? Robots are much smarter compared to that of the human being in certain kind of activities. Suppose I wanted to rotate my wrist to the certain extent without moving much of my arm, it is very difficult. But a robot can rotate. What is there in the robot? It is going to be a motor. Ultimately, motor can rotate in any direction, in any angle, any position. So, suppose if I put a kind of tool attached to the robotic arm, it can able to rotate in any direction. So, sometimes, suppose I am making a suture. Suppose I am putting a suture, I am putting a scissor to cut. Sometimes I am not able to cut like this. But a robot can rotate his arm in any direction and reach that particular position. In that way, a single robotic arm have 6 degrees of freedom. Means X, Y, Z, and rotation along X, rotation along Y, rotation along Z. So 6 degrees of freedom with the spatial movement that becomes 7 degrees of the movements. So because of that, what happens nowadays, they are much more accurate and precise. Here what happens, there will be console for the surgeon who is going to be operating with the haptic device. He will operate, make a minor movements that makes a major movements on the robotic arms, and the robotic arms will perform actual surgery on the patient. Okay, so in that one, so this is now it is coming in a better way in Indian market also. So many doctors are going for this kind of the surgical procedure, that is what is called the robotic surgery. Just open some videos of this. Robotic instrument by Dr. So this is, he is Indian doctor, he is using Oregon. See, this is called the console. He is not operating on the patient directly, he uses the console. He has certain tools there. See, these are robotic arms. The robotic arms are performing on the patient. So you can see the very, very small. So see how best they can able to hold a particular tissue and organ. Okay, so see they have a kind of where suppose you wanted to cut by heating. So you can able to pass a particular current by which the tool gets heated and you can able to make an incision. And so these are the multiple things are all robotic arms. Yes. And he will make the amount of the stress required by the doctor is very less. So he will not make much movements. It's a very minor movements which is going to enable a major movements of the tissue. So what he is doing is, what is there other? He is another advantage here. He is resting arms. His arms are rested. He is sitting quietly. Okay, and perform. So, but in other cases, he has to stand. The arms are not supported. So, suppose if the duration of the surgery is going to be 1 hour, 2 hours, the doctor becomes restless. There will be chances that the minor, inappropriate cutting and other things, mistakes may happen. So, but here it is going to be a quite comfortable condition. The doctor. Robotic. So there will be robotic arms. So you can have one will be, there will be multiple arms, but among the multiple arms, one arm will have a camera. That camera will be focusing the parts of the body where the surgery needs to be carried out. That will send the streamlined video to the doctor. The doctor is going to see this and start operating. So all these things, these are advancements which are going to vary. Okay. So for all these things again, the invasion is very less. Okay. More precise, more accurate kind of the surgical procedure can be carried out.
There is no love like you, Lord. You are the jewel of heaven, out of the crown.
So this is what I want to discuss, some of the, not my research as such, because sometimes our own research, if you start talking, it may get boring to some a diversified audience. Suppose if I talk starting on the biomechanics and the concept, so it may have an interest to the biomechanics people only. So since it is a kind of audience, a participant who have the different disciplines, I thought let us take a general concept to give an awareness what is happening in the advancement happening, because more appropriate for the advances in biomedical instrumentation. I wanted to justify that this FDP is in that particular direction only. So these are the advancements which are happening. Much advancements are still coming nowadays. Okay, so ultimately what is the goal is to make the patient very comfortable for any kind of treatment, and we are looking for either minimal invasive surgery or completely non-invasive surgery. So that is the objective of this particular concept in the advances in the medical imaging towards the surgical procedure. So thank you. If there are any questions, one or two, because our next speaker, Professor Rajesh Ajaran, is here. So That's why if you want to have one or two questions, I can able to answer. Otherwise, we will have discussion during tea time. Thank you.
On behalf of organizing committee, on behalf of all of you, I thank Dr.Mallikarjun for giving informative talk on imaging modalities and image guided surgery. On behalf of all of you, I extend a full wholeheartedly thanks and accept a small moment as well. Now we have 15 minutes break. Since the speaker is already available with us, we'll come back exactly at 12 o'clock. Thank you.